Subject: Physics. Introduction to Oscillatory Motion and its Terminologies and Simple Harmonic Motion. SHM, Grade 10. Introduction to Oscillatory Motion. Good morning, students. Today, we are going to learn about a very interesting type of motion that you see all around you. An introduction to oscillatory motion and its terminologies. The simple harmonic motion, or SHM, oscillatory motion. You have already seen this type of motion many times in your daily life, but maybe you never thought about it scientifically. Oscillation. Oscillation means a repetitive back and forth motion about a central point called the equilibrium position. Think of a swing in the park. When you push it, it goes forward, comes back, and repeats this cycle. That's oscillation. Now class, look at the graph here. The amplitude is the maximum displacement of the body from its equilibrium position. In simple words, it tells us how far the body can move from the center. The time period, t, is the time taken for one complete oscillation. For example, if a pendulum takes 2 seconds to go forward and come back once, its period is 2 seconds. Always remember, time period is measured in seconds, S. Frequency is the number of oscillations per unit time. It is measured in hertz, Hertz. Means, FF equals frequency, in hertz, Hertz. T equals period, in seconds, S. Explanation. Frequency is the number of oscillations, or cycles, per second, while the period is the time taken for one complete oscillation. They are inversely proportional. When the period increases, the frequency decreases, and vice versa. T equals 1 over F. The restoring force is the hero of oscillations. It's the force that tries to bring the object back to equilibrium. Without restoring force, the body would just move away and never return. Every system has a natural frequency, the frequency at which it oscillates freely when disturbed and then left alone. For example, a tuning fork or a guitar string vibrates at its natural frequency. That's why every instrument has a unique sound. But in real life, oscillations don't go on forever. Why? Because of resistive forces like friction or air resistance. This leads to damped oscillation, where amplitude gradually decreases over time. Think of a swing. Eventually it stops if you don't push it again. The mean position is the central position about which oscillations occur. When the pendulum is hanging straight down, that's its equilibrium position. Terminologies of oscillatory motion. We will learn about some key terms like cycle, time period, frequency, displacement, and amplitude. Now students, to describe oscillatory motion clearly, we use some special scientific terms. Let's understand them one by one. These include 1 cycle or vibration, 2 time period, T, 3 frequency, F, 4 displacement, X, 5 amplitude, A, oscillation. Cycle or vibration definition. One complete to and fro motion of the vibrating body about its mean position is called a cycle or vibration. Example, if a pendulum moves from the center to one side, back to the center, then to the other side, and returns to the center again, that is one complete cycle. Time period, T. Definition. The time required to complete one full cycle of oscillation is called the time period, T. Unit, seconds, S. Example, if a pendulum takes 2 seconds to complete one swing, then its time period, shocker, 2 seconds. Frequency, F. Definition. The number of cycles or vibrations completed in 1 second is called frequency, F. Unit, hertz, or cycles per second, S1. Formula. If the time period T0.01s, then F10.01, 100/8. Example. If a pendulum completes 2 vibrations in 1 second, then its frequency Ag 2 Hz. Relation between time period and frequency. If f-thog 50 Hz, then t-1 50.002s. Explanation. Time period and frequency are reciprocals of each other. If the time period increases, the frequency decreases, and vice versa. Displacement definition. The distance of the oscillating body from its mean position at any instant of time is called displacement, x. Unit, meter, m. Example, when the pendulum moves away from its rest position, the distance from that position is called displacement. Amplitude A, definition, the maximum displacement of the body from its mean position is called amplitude A. Unit, meter, m. Example, when a pendulum moves to its farthest point, the distance from its mean position to that point is its amplitude. Diagram, book figure 10.1. Simple harmonic motion, SHM. First, let's define SHM. Simple harmonic motion is a to and fro, oscillatory motion of a body about a fixed point, in which the restoring force or acceleration is directly proportional to the displacement and always acts in the opposite direction. That means the more you pull the object away from its center, the stronger it tries to come back. Important terms: displacement. X. Distance of the body from the mean, equilibrium position. Restoring force. Always pulls the body back toward the mean position. Example, a stretched spring pulls back. Example, a pendulum string pulls it toward the center. We have F is proportional to the negative of x. This means force is directly proportional to the negative of displacement. To convert proportionality into equation, we introduce a constant k. Here, F equals restoring force, x equals displacement, k equals proportionality, constant, spring constant in Hooke's law, minus sign, shows the force acts opposite to displacement. F equals negative kx. Would you like me to also explain this with a real-life example, spring or pendulum, for easy understanding? Nature of SHM. It is a periodic motion. Motion repeats after equal intervals of time. Example, tick-tock of a pendulum clock. So if you leave a pendulum, it keeps swinging back and forth in the same manner. Examples of SHM: a simple pendulum for small angles, a mass attached to a spring, vibrations of a tuning fork. Time period and frequency. Time period, T, time to complete one oscillation, frequency, F, number of oscillations in 1 second. So, frequency is the reciprocal of time period. For example, if a pendulum completes 2 swings in 1 second, the frequency is 1 Hz 1 second, its frequency is 2 Hz. Energy in SHM. At extreme position, energy is potential. At mean position, energy is kinetic. Total energy equals constant, if no friction. So energy is never lost. It just changes form between kinetic and potential. Thanks for watching Forces School System YouTube channel. Like, comment, share, and subscribe. Stay healthy.